Hey guys, welcome back to the channel, and today we'll be doing this spoon design inside Catia V5. This one is a simple spoon and we will utilize the shape design to model this one. Now as you can see, we have all the dimension required to model this. So let's quickly start with the design. You can go to start, shape, and relative shape design. You can name the part if you want to. Now we have two sketches. So this one is the top view and the side view. Let's start with the top view on the XY plane and let's go for sketch. Now we'll need some axis to define these dimensions. So let's start with that. You can do one axis over here, do another axis over here, and also we can do one more axis over here. After that, we'll do arc. So we have 1 2 3 4 5 6 arcs. So you can do it by using the 3-point arc or center arc, but let's say I will utilize a circle and do a circle over here. Say this one is 10 mm radii. Okay, and then this should be at a distance of 22.5, so let's give it a distance 22.5. Right, we have another circle, another arc which is of 6, so let's do it over here. Should be 6 and its distance from here should be 105. Alright, we can do this arc which is of 40, so let's go for a circle. Let's do a circle. Let's define the radii 40. Now these two should be tangents, so let's select both of them. Go for a tangency. Okay, we need another arc of 16.5, so let's go from the center origin, or you can say from the origin, and define an arc of 16.5, and then we have to make sure that these are tangency. Alright, now we can trim the unwanted sketch. So okay, I can leave it up to here. Also we can trim this one. Alright, now we have to do one more arc which is of 6. Let's go for an arc. Now whenever you are doing sketches, make sure it's not getting constrained by any other part of the sketch. It should be independent, right? So then this distance should be 18, center of the arc, so that means this is 9. These and these are tangency. Okay, and then we have to do the final arc which is of 600 radii. So let's go for arc definition 1 2 3. Now this should be tangent to this one, so let's go for tangency. This should be of radii 600. Now in case if it is big, you can always reduce its size, and then what we can do is we can, let's say, select this point and this axis, make them this point, select this point, select this axis, coincidence, also select this point and this circle, coincidence. Okay, now we can Select these two, say coincidence. Then we can get rid of okay. So this should not be up to here. This should be, let's delete the tangency relation. Let's make it up to here and then give a tangency relation. Now it's perfect. Delete this one, delete this one, this one, this one. Once our half sketch is done, we can select all the arcs, go for a mirror command with this axis. You can always go to tools and check your sketch analysis. If it is closed, that means your sketch is perfect. From here we can exit the sketch. Once we have the top view, we can go for the side view, and to do that I will select ZX plane, go for positioned sketch, reverse the H, okay, right. I will do these three arcs, so let's go for 3-point arc, 1, 2, 3. Let's define the some axis. So I'll define one axis like this and give it a coincidence with that point. I will define one more axis, give it a coincidence with this point. Okay, and then let's give the dimension to our arcs. So let's say we'll start with this one, 40, okay, then this one is 20, this one 500, and reduce the size like that and drag it over here. Alright, now we know that these points should be coincidence, and this point will be coincident to this one. And then let's go for tangency. Let's go for tangency. Okay, this point and this point should be coincidence. These two should be coincident. Now we have another dimension which is from this point to that point, 143.5. This point to this point, horizontal. That's fine. Okay. And then we have from this point to this point, 54. From this point to this point, 12. From this point to this point, 84. Okay, then we can, let's say, define uh, distance from here to this point. Let's say this is 20. Okay, so our sketch is fully defined now. Now if you see further the design dimension, you need to draw 3 more arcs, and for those arcs we have to give uh, points on these respective curves. Alright, so let's exit the sketch from here. Now we have 3 sections, AA, B, C, C. This AA section is basically the origin of YZ plane. So let's select YZ plane, go for sketch and draw a 30 radii arc. An arc of 30 radii. Make sure the center point is on the axis, and then what we can do is we have to make sure that this arc is coincident to this arc. So to do that, we'll exit the sketch. Let's go back to our sketch 2 and define a point on this arc. Can exit. And now since we have the reference, so let's go to sketch 3, select our curve, select the point we created and go for coincidence. This makes your sketch fully defined, so exit the sketch. Now there the other arc should be on BB axis, which is at a distance of 31.42. So to do that, let's define a plane. Let's go for plane definition, YZ 31.42. Okay, now we'll select the new plane and sketch a arc of 10 radii. This should be 10. The center point should be on the axis, and then we can, let's say, use that endpoint and this arc, go for coincidence. Okay, now the last should be on at a distance of 105, which is of 40 radii. So let's go for plane definition, YZ plane 105. Okay, select the plane, go to sketch, select a 3-point arc. It should be 40. Center should be on the axis, and to define the point, to define its coincidence, we'll have to define a point on the arc. So let's go back to our sketch 2 and define a point over here and give it a distance of 105. Okay, then we can go to our sketch 5, select the sketch, select the point, coincidence, exit the sketch. Now we have all the necessary files, necessary sketch. So let's start with the sweep command, and let's go for with reference surface, profile, right click, extract. This one, okay. Right curve is this one, okay. Another sweep with two guide curves. Right click, create extract. This one, okay. Guide curve one should be this one. Right click, create extract. This one, okay. Okay, so once you have all, this should be opposite actually. So let's go for split, join one, extrude one. If you see like this, go for other side and press OK. And if you hide your sketch, your spoon will be ready. If you see, this is something, so let's correct our sketch 3. Exit. No, I think that's the perfect spoon that we wanted actually. So after this, you can switch your workbench to part design, go for thick surface, select your split, and give the preview and then hide your, you can also hide all your curves, all your planes, all your sketches, and this is your spoon ready. You can give material if you want to, so let's go for plastic material. Okay, that's how you can design a spoon in Catia v5 using generative shape design. And this was according to the dimension that we have over here. So yeah, that's it for the design. I hope you guys like it, and if you have any doubts with this one, feel free to comment down below. Also subscribe if you are watching this. See you in the next tutorial. Peace out.